Hey there, welcome back, and let's talk about percent composition today. We are going to be focusing on percent composition by mass. And what this is what is the percent of a portion of a sample as compared to the whole? So what's the mass of a particular piece of a sample, whether that's an actual sample of a chemical compound or a formula, but what's the mass of that piece divided by the total mass? And then to make it a percent, we'll multiply it by 100. One of the most common places you'll see mass percent is when talking about the mass percent of a particular element in a compound. So for example, finding the mass percent of sodium in the compound sodium carbonate. In this case, the part that we're interested in is the mass of the sodium. So I'm going to find the grams of the sodium, and I'm going to divide this by the grams, the mass of the entire compound. And sodium carbonate has the formula Na2CO3. I'll take that and I'll multiply by 100. It's easiest to assume we have 1 mole because then we can just use the molar masses of each piece for these grams that I have indicated here. So the total mass of sodium in the sodium carbonate is going to be 2 times 22.99. That 2 is because it has a subscript of 2. So there are 2 sodiums, each which would weigh 22.99 grams in every 1 mole. And then I will divide this by the total mass of the compound, where I add up all the pieces. And so my molar mass is the 2 sodiums, the carbon, and 3 oxygens. And I'll take that and fraction and then multiply by 100. When I do that, I get 43.38%. So finding the mass of a particular element in a compound is one thing that you will see often done with percent composition. You can take that same idea and use percent composition as part of a larger problem. So for example, let's say I have a sample of iron 3 oxide and I've got 0.450 grams. And I want to know, well, what's the mass of the iron in that sample? Well, if I know the percent composition, I can then use that in combination with the mass to figure out the mass of just the iron. So let's find the percent composition of iron in iron 3 oxide. The formula for iron 3 oxide is Fe2O3. You obviously need to start with the proper formula because the subscripts impact your math. So in this case, the iron is the part that we're interested in. So I'm going to put that on top. And in a mole of iron 3 oxide, the mass of iron will be 2 multiplied by 55.85. That's the molar mass of the iron itself. And then the total mass of the iron 3 oxide will be the 2 irons and 3 oxygens. And this is 69.9%. So it's 69.9% iron. From here, we can just figure out, well, what's 69.9% of that sample mass? That'll tell me the mass of the iron. So to do so, I'll take the 0.450 grams of the sample, and I'll multiply this by 0.699 because that is the percent in decimal form, that is the iron. And I find that I have 0.315 grams of iron in this sample. To emphasize this 0.699, remember that this is because there are 69.9 grams of iron in every 100 grams of the sample. That's what it means to be a percentage. It's the part over the whole. And so I'm just multiplying by that percentage in decimal form to figure out how many grams of iron are in that sample. These problems, this one and the one before, are both focusing on the mass percent of an element, either standalone or as part of a larger problem. But you don't have to stop just at a particular element and always just look at elements. Again, mass percent can be for any part over whole. So for example, if you have borax, you find borax in the laundry aisle at the grocery store. It's used for like laundry booster and cleaning. If you read the box, it can do all sorts of things. But borax is actually sodium tetraborate decahydrate, which means there's sodium in it, there's boron and oxygen, that's the borate piece, and there's water, hydrate. decahydrate. There's water trapped in the crystals. That's what a hydrate is. And so I could figure out what's the mass percent of water in the borax. All I need to know is how many grams of water do I have, the part that I'm interested in, and how many grams do I have of the entire sample. Well, the last sentence here tells us that if in 5 grams of borax, there'd be 2.36 grams of water. So I can find the mass percent of water. And so again, by taking the part, that's what we're interested in, dividing it by the whole sample, multiplying by 100, I can find my mass percent. In this case, 47.2% water, but it could be done for an element or for any other part of a larger sample.